Hi there, I'm going to be talking about 2x2 systems and solving them specifically by elimination or using the elimination method. For this to work, we need to make sure that we have opposite coefficients of the same variable. So what that means really is when our equations are ordered similarly in the same order, we want to start looking at the coefficients of the same variable. So first we can start looking at x. X up top has a coefficient of 4, x down low has a coefficient of -4. That is exactly what I am talking about. One is positive and one is negative, and they are the exact same number there. That is opposite coefficients. If I am looking at this and I see a -1 here with the y, down below this would need to be a positive y. If this was a -4y, up top would need to be a positive 4y, and those are the opposite coefficients of the same variable. Some of these problems will end up with the opposite coefficients given to you immediately to begin with, as is the case here. When that is the case, we can smash these two together, we can combine them. And what happens if you do this correctly, one variable will disappear. So in this case, the x's will be going away. 4x and -4x is 0. It is nothing. They are gone. We will combine these two to give us -5y. 20 and 20 will be 40. This is my new equation, and we have done it correctly. We can tell because we no longer have an x. One of our variables is gone. We have eliminated it. Now we can solve this. Divide both sides by -5. Y equals -8. That is perfect, and just like all your other systems that you have been dealing with, we are then going to take this and substitute it back into one of my original equations. I will choose the top one right here. So I have 4x minus y equals 20. What I am substituting in is a y value of -8. So I get 4x plus 8 equals 20. Subtract 8 from both sides. 4x equals 12. Divide by 4. X equals 3. The point of intersection will be 3, -8. That is a system by elimination. I'm going to do a few more. Specifically where we need to start changing some of our equations. Let's take slide it up a little bit there. How about a 6x minus 12y equals 24. Let's do a little color change here. How about a -x minus 6y equals 4. Okay, so looking at this, if we are to solve this with the process of elimination, we need opposite coefficients of the same variable. That is +6, that would need to be a -6. That is -x, that would need to be +x. If that is -12, we would need a +12. If that is -6, we would need a +6. So nothing is opposite. We are going to need to do some modification. And we are going to modify through the process of multiplication here. We can multiply one or both of these equations to get opposite coefficients. I personally believe that this system of equations would be best suited for a multiplication by -2. And the reason I am doing that is because I see a -12y right here, and I am thinking that, hey, if I can multiply this term right here, this -6y by something to get the opposite of that, I can be in pretty good shape. So -2 times -6 would give me a +12y. Now we would end up with opposite coefficients. So let me rewrite these equations here. My top one is unchanged. 6x minus 12y equals 24. Down below, I will rewrite it in a light blue now to show we have multiplied. I get a 2x plus 12y equals -8. Now looking at this, I see opposite coefficients of the same variable. That's what we're looking for, a 12y and a -12y, and we have them. So now I can combine down. I will get 8x. Those are gone. They cancel. And I end up with 16 on the other side. 8x equals 16. Divide it by 8. And x equals 2. Halfway there, take it and sub it right back into one of our original equations. Does not matter which one you choose. I will use the bottom one. It seems slightly easier. So we have negative x minus 6y equals 4, and my x value here is a value of 2, so 2 will get subbed here into these parentheses. Negative 2 minus 6y equals 4, add 2. Negative 6y equals 6, divide by negative 6, y equals negative 1. Point of intersection, 2, comma, negative 1. There we are. That is where those two graphs intersect. Okay, I'll do a couple more for you. How about we start with an x plus 7y equals 0. And then 2x minus 8y equals 22. System of equations. Let us solve our system. Looking at this system, I see that we do not have opposite coefficients of the same variable. So now thinking about it, we could change these two. What would be common amongst these two when we multiply up? I think we could get them both to 56, but that would require multiplication by 8 and then multiplication by 7. I think if we change and we modify one of these x terms, we're going to be in better shape. I see a 2x here, and I know that I can multiply this top equation by a value of negative 2 to make it opposite. Then we will end up with opposite coefficients of this x. So let's see what we get with our new equations. Okay, modified top one this time, negative 2x minus 14y equals 0 still. My lower equation, unchanged, 2x minus 8y equals 22. Now I have opposite coefficients of this x variable. Fantastic. Add those together. The x terms cancel. I'm going to be adding here, and I get a negative 22y equals 22. Divide both sides by that negative 22. And you end up with y equals negative 1. Take it, sub it back in there. I will put it into the top equation, the original unchanged. X plus 7y equals 0. And we are subbing in a y value of negative 1. Clean it all up and see what happens here. X minus 7 equals 0. Add 7. X equals 7. 7, comma, negative 1. Point of intersection, solution to the system. The point that satisfies the system, it is the one point that they share in common. All right, let's look at 4x minus 3y equals 11. And 3x plus 2y equals negative 13. Okay, so now looking at this system, I do not have opposite coefficients of the x. I do not have opposite coefficients of the y. And thinking about this, I'm going to have a tough time changing just one of these to become opposite. So, therefore, I will need to change both of my equations. One thing that I do notice is that they have opposite signs of my y variable. Therefore, I can multiply both by a positive. So what will 3 and 2 have in common when we start to multiply up? And the smallest value that I can see would be 6. So what do I need to multiply negative 3y to change it up to a 6 value? Okay, so how about a 2? That will take me to a negative 6y. And then on my lower equation, if that is going to be a negative 6y, this will need to be a positive 6y. The way I'm going to get that up to a positive 6 would be multiplied by a value of 3. So now when I change these equations, let's take a look at what we end up with here. 8x minus 6y equals 33. My lower equation, 9x plus 6y equals negative 39. Okay, so let's see what is happening here. I believe that I have made some sort of small error, possibly a large error. Let's bring them on down. I get a 17x. That cancels, and I would end up with a negative 6 value right there. That is not working out the way that I planned it. Wow. 22. Giving me then negative 17. I can't believe I froze for that long. X equals, pardon that, x equals negative 1. Take it. Right back on in there. Let's see what we get. I would choose the top equation. Does not really matter. 4x minus 3y equals 11. Subbing in a value of negative 1, negative 4 minus 3y equals 11. Add 4 to both sides. Negative 3y equals 15. Divide by negative 3. Y equals negative 5. Solution, negative 1, negative 5. Thank you very much.